Hello and welcome to this tutorial by Weibull Analytics. Today we look at survival analysis. What is survival analysis? This is simply a collection of statistical procedures for analyzing data for which the outcome variable is time until an event occurs. This event can be negative like death, but the event can also be positive like recovery from a disease. So to better understand what survival analysis is, let us look at the basic structure of a survival dataset. Here we have got 5 participants, the time for which they were observed in months, and the status. In this case, it is death, 1 indicating whether the person died, and 0 indicating whether the person is alive, and the period for which they have been observed. Then the treatment group where they belong, whether they are receiving treatment A or treatment B. Now here are very common terms that you need to familiarize with in survival analysis. One is the survival time, which is the time from a defined starting point. For example, diagnosis, the time at which you diagnose that this person has malaria, or it can be enrollment of your study, to the occurrence of the event. And if you look at our sample data set here, person number 1, person number 3 and 4, they all had events, but they were observed for different time points. Another important term is what we call event, or sometimes referred to as a failure, which is the outcome of interest. Our case here, the event is death. It has either occurred or not occurred. But the event can also be a relapse or sometimes a positive event like recovery from a disease. And it is usually coded as 1. When you look at our participant 1, 3, and 4, they had events. The events occurred. In this particular case, they died. Another key term is called censoring. When the final event did not occur during the study period, or probably the patient was lost to follow-up, or the study ended but the person is still alive, that is called censoring. When we look at our data, person number 2 and number 5, they were censored. The event didn't occur during that study period. We also have the status indicator. We've already looked at it. 1 indicates the event has occurred, or 0 indicates the event has not occurred. And we also have the group variable, or the strata, which is a categorical variable for comparing different populations or treatments. For instance, if you want to see to compare the survival times for people receiving treatment A versus those receiving treatment B, and you see which one is maybe higher than the other, or whether there are statistically significant differences, then that is the grouping variable. Sometimes you have very many explanatory variables. So here we only have 1, but you may have other more variables to explain survival. Besides those ones, there are also other 2 important variables that you keep coming across quite often in survival analysis, during interpretations, during reporting, and that is survival function and hazard function. The survival probability or the hazard. And what are these 2 terms? Let's look at survival function. This is the probability that a subject survives beyond a time t. It is equivalent to asking yourself a question: what is the chance that a person is still alive or hasn't had the event of interest after a certain time? And it starts at 1 or 100% when everyone is still alive at the beginning of the study, or when everyone has no event. If you are looking at death, everyone's still alive. If you are looking at a positive event like recovery from malaria, everyone at the start has malaria at the start of the treatment. And over time, as people experience the event, like the death, relapse, or dropout, or recovery, the survival drops. On the other hand, when we look at the survival function, it is the instantaneous rate of event at time t given survival until that time. This is similar to asking yourself a question. If a person has survived up to now, what is the risk that they will have the event right now as we speak? Okay, so it is the instantaneous risk of event at a certain moment, given the person has made it that far. And unlike the survival, this is not a probability, but instead it is a rate. It is showing us how fast are things happening. Okay, so in simple terms, when you're looking at survival, what's the chance that the person is still alive or has not yet gotten the event, has not yet recovered if the event is positive after a certain time? Whereas hazard, if a person has survived up to now, what is the risk that they will have the event as we speak within that short period of time, that minimal, that instant? It is also important for us to know what are the goals of survival analysis. For us to know this, we need to remember that with survival analysis, we are looking at time to event or survival time. So there are three main objectives or goals of survival analysis, and these include: one is to describe the distribution of that survival time given survival data. And here you're looking at either survivor or hazard functions that you're using. And secondly, survival analysis aims at comparing distributions of survival time for different groups. Okay? And lastly, to assess the relationship of explanatory variables to survival time. This is simply looking for factors associated with the survival time. Let us look at the first goal of describing the distribution of survival time. This is equivalent to running descriptive statistics for survival time. And here we look at average survival time, the median survival time, and the average hazard rate. For comparing distribution of survival time between groups, here we can still compare the descriptives between groups. For example, we are comparing males and females. We can look at the mean survival time among males, whether it is higher than among females, or we can look at the hazard rate among males compared to females. That's just comparing the descriptives. Next, we can use graphical approaches. We plot graphs for one group against the other, and we see which one is higher or which one is having lower survival. Or else we can use statistical methods. We can use the log rank test, or what is called the Mantle or the Cox test. We also have the Wilcoxon, also called the Breslow test, or the log rank test, but for ordinal data. To achieve these two objectives, commonly we use Kaplan-Meier and lifetables. However, these methods have got two major limitations. That is, one, they don't give you a point estimate. You can't get, for example, odds ratios which logistic gives you. Here we can't have such an estimate. And secondly, they can only compare groups of just one single variable. You can't have several variables compared at once. Therefore, if you have more than one variable, one explanatory variable, you need to use other advanced methods that we are going to see in Objective 3. So for Objective 3, which is aimed at assessing the relationship of explanatory variables to survival time, or in simple terms, factors associated, we have got two groups of tests that you can use. One, the same parametric models, which other books refer to as non-parametric models, and this includes the Cox PH model, and it is extended version, the extended Cox PH model, to handle time dependence. The other types of models are the parametric models, which include the exponential, the Weibull, the Gompaz, the log normal, log logistic, and the generalized gamma models. However, in practice, you'll find that the non-parametric models, the Cox Proportional Hazards model, and its extended version, the extended Cox PH model, are the commonly used, for reason being they do not rely on the shape of the survival curve. Survival times often do not fit neatly into known distributions, which are the key component of parametric models. And if you choose the wrong distribution in a parametric model, your estimates and inferences may be misleading. That's why most times you'll see people reporting using the Cox PH model and the extended, the semi or the non-parametric models. I hope now you have a good overview of what survival analysis is, what are the objectives and the different tests that we have under survival analysis. So in our next episode, we are going to look at Kaplan-Meier analysis, which is used for describing the distribution of survival time and for comparing distribution of survival time between different groups, and also look at the log rank test, which is one of the tests used for comparing distribution. If you find this video useful, consider liking and subscribing to our channel so that you don't miss out any of our episodes. See you in the next video.